thought I'd just make a video on a few checks you can make to your alternator if you suspect you've got a faulty one. So the first thing you're going to notice is probably some sort of warning symbol on your instrument panel. But what you can do next, you can just come to your alternator, make sure that your auxiliary drive belt is in good condition and it's got the grooves intact there and it's not slipping. Obviously it could have some oil on it if you've got an oil leak, and that would cause it to slip. So you want to check that, and then you can also check that it's got tension. So you can just press the side of the belt, make sure it's got enough tension there. And some of them have indicators, so here this would mean if this line here goes past that one, that would indicate that it's stretched too much and it needs to be replaced. And you can just make sure that the pulley is turning. So we're going to do that now. So we're just going to pull that back, see that that spins, and then just tension it back again. So the next thing you want to do is just make sure you've got the correct battery fitted, and also there's no bulges around it or acid powder, which would indicate you've got an overcharging problem. And then just check your battery voltage, negative obviously to positive, and you should get 12.6 volts for a fully charged battery. Obviously if it's not there, or it's lower than that, if it's 12 volts, that's going to indicate like a 25% charged battery, so that would indicate that perhaps your alternator isn't charging it. So when we turn the engine on, we're going to look for higher than 12.6 volts because we want the alternator to be charging the battery. So what we're going to do, we're just going to start the engine now, and we should see that voltage increase as the alternator is then charging the battery. So you can see now that the alternator is charging the battery. Now we want to make sure that the regulator is keeping that voltage constant, so we can apply a load to it by turning on the headlights. And you can see that it's maintaining that voltage still. And then what you can do, you can then rev it, take it up to 2000 revs. And you can see that it's still maintaining that voltage. If you don't get an increase in voltage when you turn on the engine at the battery, you want to test it directly at the positive connection on the alternator. So the next thing you can do is just make sure you have a positive connection going from your alternator to your battery positive. So going from battery negative to the positive connection there of your alternator, you should get battery voltage. So we've got a connection there. Now we also want to make sure that we've got a good earth connection, so what we're going to do, we'll just put our positive multimeter into our battery positive, and then we're just going to put our negative connection on the casing of the alternator, and we should get battery voltage there. But we don't know whether they are a good connection or whether there's corrosion on the connections. So that's what we're going to test now. So we're going to turn the engine on, we're going to put it under load by turning electrical systems on, such as headlights and the heated screens. That will send through maximum current, and then if there's any resistance between the earth connections or positive connections, we can pick that up as voltage. So we're going to go from positive of the alternator to positive of the battery and measure the voltage there while it's under load and running with the electrical systems on, headlights, and we're going to go from the negative of the battery casing of the alternator to the negative of the battery and test the voltage there that we pick up. And a good connection, I believe you shouldn't get more than half a volt there. So we're on battery negative, we've got the engine running, we've got the headlights on, and we're just going to go to the casing of the alternator. So we've got a good earth connection there. If we didn't, we'd be in effect measuring a resistor in between the alternator and battery negative, and so that would show up as a higher voltage. Okay, so now we're going to test the positive line, so we're just going to go from battery positive and with the other line we're just going to go to the positive of the alternator. So we've got a good connection on the positive line there. So the other wire you're going to have going into your alternator is this one here, and that's basically going to an electromagnet in the middle, and that's going to change in voltage, which in turn changes the electric field, which increases or decreases the voltage that the alternator puts out. But it's still not going to be a perfect DC voltage, so there's going to still be some AC picked up from your battery. So we're going to test that now, and it shouldn't be more than 100 millivolts. So we've got it on AC there. Now the electromagnet that's in your alternator is going to get supplied with varying voltage, so we're going to just test that now, apply load, see if it changes with the multimeter, and then see what it looks like with the oscilloscope. So we're just going to back probe there and then connect that to battery negative and see what that looks like now. Right, so we've just got that regulator back probe there, and we check on our multimeter. We've got 13.9 volts, and you can see that it's supplied with a maximum of 16 volts, and that's duty cycled, so it's averaging about 9.5 volts there. So the last thing you can do is a ripple test. So I've just got the oscilloscope hooked up to the positive of the alternator and the negative of the alternator casing. So you're going to get the best signal if you do it from there. And this is going to pick up the AC or the rectified AC output from the alternator. And you're just looking for any gaps or big dips there, which would indicate the diodes of the alternator are not working correctly. Now looking at the voltage ripple test, it's not the easiest thing to look at because there's lots of spikes in it anyway. So if you've got an amp clamp and you can get onto the alternator positive cable easy enough, then this is a good one to do. So just put your amp clamp around the cable, make sure you zero it, which is what that glitch was there. Zero the amp clamp, and then you can see a much better ripple test. So again, this is the rectified AC output from the alternator, and so this is actually the current, and this is the top of that three-phase sine wave. So it's just looking for any gaps or dips in it, which would indicate that you've got one of the diodes out in the rectifier. So I've just got that clamped there around the positive output of the alternator. Just for comparison, here's the voltage ripple and the current ripple. You can see you can get a much clearer signal with the amp clamp.